Today we are going to listen to two presentations. One is about nutrition in berry crops which are grown in the soil. Berry crops are still an increasing market, and as a grower we want to have a good quality product and a high yield. And that's why we like to have a balanced feeding so we can get to the best result. Our first speaker who's going to talk about this is Adrie Streef from Delphi. Adrie has been many times in Ukraine, has seen many farms, so he really knows Ukraine very well. The second speaker will be Marcel de Jong. We hear a lot about regenerative agriculture. And what is it now exactly? What is the concept? And also what are the advantages of it? But we start with Adrie Streef. When you want to ask something, then please raise your hand. You can see it in the banner below in your screen, or please write your question into the app. Then we will see it, and then after the presentation there will be an opportunity to ask these questions. Okay, then I like to go to Adrie. Please, Adrie, the floor is yours.
Thank you all for having me on this interesting meeting. I hope we have a good discussion. I prepared some issues about fertilizing and water. And if people have questions, please ask them. It's a short presentation, so I cannot take all the topics, but probably there will be questions enough to discuss enough. Valerie, already thank you for the opportunity.
Just a little bit slower if you can, please.
Okay. This feeding of fruit crops in the soil, I limited to strawberries, raspberries, and blueberries, and they require special needs and attention in comparison to other field crops. So you cannot compare strawberries with other arable crops. They need special attention. Very important is also the balance in feeding to get a high quality crop. More fertilizers is not always better. So the balance is very important to give just enough, and not overfeeding and not underfeeding the plants. A little bit about our company, Delphi. We are an independent consultancy company. So we do not sell plants, we do not sell fertilizers, we do not sell anything of that, only we sell our knowledge. And our clients are mostly growers. And growers, we are based in the Netherlands, but we have clients all over Europe, and we are also active in Asia and Africa. We give mostly technical advice on growing of all types of plants. This goes from flowers to perennial trees, and I have about 200 colleagues for all these different crops. Soft fruits is a quite special part of our company. We have 3 teams. One is based in Netherlands and Belgium, about 20 people. We have a group of colleagues in the United Kingdom, in England, about 10 people, and we have also a small team in Poland at the moment. Next to that, we do also our own research. We have built in 2012 our own research station for soft fruits. It's placed in Horst, Netherlands, and it's called ESFC, which is International Soft Fruit Center. Also, we do organize international meetings and events for the different topics of soft fruits. And this is also one will be organized in January again in Den Bosch, Netherlands. Research, what is done, is mostly done on substrate cultures. So we do substrate cultures, strawberry. We have a test on the blueberries substrate, and we also do raspberry and blackberry. My name is Adrie Streef. As I told you, I'm almost 40 years active as an advisor in soft fruits. I'm born on a company which is growing apples and pears and cherries. And about 20 years ago, I went mainly to soft fruits in order to give growers advice. And I do that in Netherlands, but also in Germany and in many other foreign countries. I was on and off in Ukraine since 1999 when we have our first project there. I give advice on strawberry, raspberry, blueberry, and other berry crops. And the topics that I find is about feeding of the plants in the soil and in substrate, disease control, planning of the crops, etc., etc. I also am interested in the economics of crops, so I make business plans, I do cost price calculations, and all those topics. How to start a crop? First, you look at the soil. The soil is very important when you want to grow in the soil. The second is the quality of the water. The water is, soft fruits require high demands of the quality of the water. And also you look at the climate conditions. Is this an area where there's a lot of frost in winter? Is there a lot of frost in spring? Is it very hot in summer? Is the hail very active? So that's also a very important part to find the best place for your company or the best place for your crop. About climate conditions, we will not go further in this presentation. When we look for a good soil for strawberries or raspberries, we need a pH in the soil between 5.5 and 6.5. When the pH is higher, it's not impossible to grow strawberries or raspberries, but it's more difficult. Also, what's very important that the soil is not too alkaline. So strawberries are not alkaline resistant crop. So when the sodium amounts in the soil are too high, it will give real big problems in the quality of the fruits. So we want a lower amount of sodium than 20 milligrams per kilo soil. Very important also that the plants do not have wet feet. So the soil has to be drainaging very well from nature, or it has to be drainaged before planting. If possible, organic matter in the soil will help to keep moist on a good level. So if the soil does not contain any organic matter, then maybe it is interesting to grow an other crop before that to improve this. The feeding of strawberry and raspberry. We start at a field where the chance of soil diseases is very low. Soil diseases like verticillium and phytophthora are quite regular in these crops, and other issues in the soil with structure can make this diseases much more a problem. So, no wet spots is quite important to have a good growing crop. Also, it's very important what was before on this field. If people have grown the potato, pepper, tomato, plums, cherries, raspberries, or other berry types, it can have infection of verticillium. So verticillium is very difficult to get rid of. So be aware of that the land is not grown the last 5 years with those crops. Otherwise, you can have, especially in strawberry, really big problems with verticillium. And then what we see is that a number of plants do not grow when they have some stress. That means very small berries and the plants are dying. Here are 2 photos of strawberries growing in the soil. What most growers do is use raised beds in order to have a better combination of air and soil and water. Those raised beds are a little more costful than planting directly in the soil, but the average higher production will be about 20%. So, especially for the fresh consumption, growing on a raised bed is interesting. You see here 2 photos, one with black foil and one with white foil. The black foil is to get an early crop, and the white foil is to have a crop which is later in the summer. So the white foil makes the crop a little bit slower, later production, and the foil makes the plant not as hot as the black foil. The black foil we use for the early cultivars, the June bearers, and the white foil is more used for everbearers, which has to produce all summer. The water quality is very important. What we have seen in Ukraine, but also in other East European countries, is that the amount of sodium can be quite high, and that gives issues in strawberry growing. So what we would like is to have a water quality which has less than 1 millimole sodium, and that means 23 milligrams per liter. If this is higher, then we can have problems in the taste of the fruits and also in the firmness of the fruits. And sodium is a competitor of potassium. Potassium is the most important element for having big fruits and having tasty fruits. And when the potassium is compared too much by sodium, then there's an issue. Also, boron can be an issue. We have seen too high amounts of boron in the water. And in most crops, there is no problem at all. But also in raspberries, there's no problem, or in blueberries. But in strawberries, that can be easily be overdosed. So when we see too high amounts of boron in the plants, you see the leaves, the sides of the leaves are burned. pH of the water can be between 5.5 and 6.5. When the pH is higher, we have to add acid to the water to make it a little bit lower. Also, the total amount of elements should not be higher than 1 millisiemens. So the EC has to be measured. When this EC is too high, then it's quite costly to make the water clean, but it can be done with reverse osmosis. But this is a big investment. This table, we see the different elements, where the maximum amounts of how many there may be in the water. So we see potassium, maybe maximum 5.5 millimole, that is 250 milligrams per liter. Calcium, we never see that. Calcium also can be about up to 130 milligrams per liter. Magnesium, we can have 30 milligrams per liter. Nitrate, up to 713 milligrams per liter. And sulfate, 244. Phosphor, 32. These elements are mostly no problems. When we find those elements in the water, it's already a free feeding for the plants. These are fertilizers you don't have to buy. The sodium is a problem. There's not any good to the plant. Also, the chloride is also damaging, but the border for chloride is not as high as for the sodium. The silicium can also be an issue in strawberries and other crops. Silicium can be a good thing to make the plant a little bit harder and resistant against the mildew. But in strawberries, it can affect the quality of the fruit, and it can give what we call albino fruits, so fruits which do not color. When we look at the microelements, then we see iron, manganese, zinc, boron, and copper. Out of the boron, the other elements are not so much an issue. Only when iron is very high, it can be difficult for the drip lines and so on. We have the same line for the water quality for raspberries cultivation. We see that it's a little bit more forgiving than the strawberry. The sodium, we can go up to 1.5 millimole, so that's about 35 milligrams of sodium per liter water. And the other ones are okay. So strawberries is a little bit more forgiving for a questionable water quality than the strawberries. You will have this presentation, so you can look up these figures later as well. Now some issues on the different elements. The most important element is always nitrogen. As you know, there are two, maybe three types of nitrogen. Ammonium and urea, they are almost alike. They give strong vegetative growing in plants, and it also lowers the pH. But is also competition for calcium and potassium. So when a plant has to start making roots, have to start growing, we like to give a little bit more ammonium to the plants for a good growing, vegetative start of the plants. Nitrate is more for the normal development in the plant, and this gives so we give them the most part of the nitrate, the nitrogen in the plant we give in the form of nitrate. We use in the start a little bit of 1 millimole ammonium during the vegetative development of strawberries and raspberries. And when we are cropping, so we are picking the fruits, when the fruits are ripe, we do this as low as possible. What we see is that because of it is competitor of potassium and calcium, the fruits are weaker when we give a lot of ammonium in that time, especially in strawberries and raspberries. The second most important element is calcium. These are the building blocks of the plant and the plant cells. And for the plant, uptake of the calcium needs energy. So good developed roots are very important for the uptake of calcium. It is not easy to transport in the plant. If we compare it with potassium, which is very easy to transport in the plant, but the plant has to take energy to transport the calcium. The water or fertilizers need to contain up to 130 milligrams of calcium per liter. The calcium nitrate is the basis of most of the feeding, especially when we grow on substrate, but also in the open field. I also mentioned already potassium a number of times. It's very important for fruit size in strawberry and raspberries. Also the fruit firmness and also the fruit taste. If we see that the firmness of the fruit is poor, and that can happen when we have very warm nights, or when the amount of ammonium or sodium is very high, we give higher amounts of potassium, and that can improve the quality of the fruits in 1 or 2 days. We also increase the amount of potassium in the time we pick our fruits. This means that we have a schedule before we pick fruits and when we start picking fruits. So 2 schedules. In strawberry, we can see the results of added potassium in 1 day, when fruits are weak or not tasty. Magnesia. Magnesia is very important for the color of the fruits and also the shininess of the fruits. What we often see is a manganese shortage, and this photo shows how this looks like in the strawberry plant. If you use NPK fertilizers for overhead fertigation, so not so the pellet fertigation which you throw under the plants, we need NPK fertilizers containing about 12% nitrate, 12% potassium, and 70% potassium, phosphate and potassium. Total, we need about between 70 and 80 kilos of nitrogen and 150 to 200 kilo of potassium. Amount we give is based on the soil and the soil research. So before we plant, we want research of the soil, what is in the soil already and what we need to give extra to grow the plants. Much better is to use drip irrigation, so you can give the feeding on a weekly basis to the plants. When the water does not contain a lot of fertilizers or feeding elements, we give the NPK in about between 20 in the start. Weekly, this is about 3 kilos of nitrate per hectare, and we start with giving feeding in the strawberries when the first troughs develops. The first troughs are the small flowers under in the plant, below in the plant, and when they start to develop in the spring, you have to start feeding. If you start much earlier, then you delay your plant. When we are cropping, we change our fertilizers so that the nitrate and potassium is between 1 and double amount of potassium of the nitrate we give. So we can give then NPK like 15, 5, 30 or something, which is like that. We also need weekly about 3 kilos in this period, depending how high the crop is. So when you have a low crop, then we give less nitrate. When we have a high crop with a lot of fruits coming, then we give more nitrate. Of course, we also give much other advices in the feeding of the plants, but these are the base rules. Growing raspberries in the soil. What we see is the development of people growing more and more raspberries in substrate pots. But also still raspberries are growing in the soil. What we see is that when you grow in pots, the production per hectare is double as high as in the soil. But today we talk about raspberry production in the soil. Compared with strawberries, we give about the same kind of fertilizers, but we start when the first leaves are developing on the canes, and we start then with about 2 kilos per week. And when the first flower.
Adrie, we don't hear you anymore. I don't know what is happening, but I don't hear you anymore. Can you continue, please?
Adrie, something is wrong with the sound. We don't hear you anymore. Could you please switch on the sound? I think something with your microphone. I don't hear Adrie. Does anybody hear?
No.
Just call him and I will just see what's happening.
Yeah. Okay.
Okay.
Adrie, we can hear you again. If you can go back to the slide with the raspberry feeding, then we can start from there on, because something was with the sound.
Everyone can hear me again?
Yes, we can hear you. Yes, we can hear you. Діма, скажи, що ми його чуємо, щоб він вибрав. Yes, I can hear you.
We not so much. Did you put it on the language, Adrie, on English?
I check.
Because I hear you very far away, but please continue.
Yes, we continue.
Yes, good.
Do you hear me, Adrie, now?
Good. Yes, you can continue, Adrie.
Yeah, okay.
Yes, please.
Good. From red fruits, we go to 3 kilos per week of nitrate. The blueberries, the quality demands for the water is the same like raspberries, but the pH must be lower than 5. That it's quite different crop than the other soft fruit crops. When you grow in the soil, also the pH of the soil must be lower than 5. If not, then better grow on substrate. When you have too high pH of the soil, it's only possible to lowering it margins in marginal. We can use sulfur flakes, and to get from 5.5 to 5, we need about 300 to 400 kilos per hectare. And also this will work very slowly. What we can do is when the quality of the soil is not good, we're building a ditch in the soil and fill that with substrate, mostly peaty moss, sometimes mixed with perlite or bark. Or grow in pots. The problem is with pots, the roots can freeze in winter, so we have to be sure that the pots are covered against the wind in the winter. Here we see some blueberries in the correct soil. Blueberries can get very old, those plants, if the cultivars are still good. And you see the plants can have a height of 2 meters and even higher if you don't control them. Here next to you see a photo, they used also a hail cover in order to have the plants not damaged by hail. Unfortunately, there are also people who planting blueberries where it should not, so then you get problems. And one of the problems you see here is a blueberry which is very yellow. So and the pH of this soil is not correct. And also here, in all plantation where the pH is not correct and plants will not grow or grow very poorly. So having the correct pH is very important. This is a photo of a plantation where they have substrate in pots, and they lowered it into the ridge, into the so to have no problems in the winter time. Very important, of course, in this system is that the drainage of the pots will not make the bottom of the pots too wet. Otherwise, we also get problems because blueberries do not like wet feed. Feeding of blueberries is different from other crops. We talked about the different types of nitrate, like ammonia and nitrate. Nitrogen, dus ammonium and nitrate. And for the blueberries, it's very important that we have enough ammonium because it takes that better up than the nitrate. Also, what is forgotten a lot in the feeding of blueberries is calcium. Calcium is needed for having a firmness of fruits. And this is getting more and more important because clients want big and firm fruits. In the soil, when people do not have drip irrigation, they can work with slope releasing fertilizers. And then we need between 50 to 70 kilo of nitrogen per year in a full-grown plantation. Of course, better is to give water with drip irrigation because you can steer that way the amount of water you give to the plants, and also you can feed much more regular, so the plants will grow better. In this list is what we give when the plants are in pots with drip irrigation. And then we see the different elements here. The EC is 1.3 in the feeding schedule. You need about, these are the millimoles. So we give about 2 millimoles of ammonia, 3.25 of potassium. And in the start, we give a little bit less. And in the cropping, we give 1 millimole more. We don't give sodium, of course. Calcium, we need about 2.5. 2.25, magnesia 1 millimole, nitrate about 5.25. In the start we give 1 millimole more. Sulfate we give 2.5 millimoles and phosphate 1.5 millimoles. Bicarbonate we don't give that to the plant. Bicarbonate, HCO3 is the element which makes the pH high of the soil and the water. And that's why we don't want to have that in the fertilizers or in the feeding. The microelements, standard is about 20 micromole of iron. And in the cropping, we top it up with 12.5, so we have to get it 32. Manganese is normally 10, and we high it up with 7.5 millimoles. Zinc and boron are between 7, 15, copper, and a little bit of molybdenum. So this is a little bit how the different elements are in their combination. This then should be the end result, having a good, tasty and firm strawberry, have a good raspberry for the fresh market, and have a very tasty blueberry. So I want to thank you for your attention. This is my contact email, and I hope we are open for questions now.
Yes, thank you very much, Adrie, for this overview of different crops and all different nutrients in a nutshell. We have 2 questions. The first question I can read for you. Fertilizing raspberries in the beginning, 2 kg of 2620 per week. It's a number in active ingredient.
Yeah.
Okay, that's clear.
Correct, yes.
And then Valerie, can you read the next question?
Adrie, do you hear me? Because I'm not sure that Adrie have selected English language. Do you hear me, Adrie?
Yes.
You hear me?
Yes.
Okay, very good. So the second question is regarding lowering the pH of the soil with the drip irrigation. Does it make sense to use phosphoric acid, or only nitric and sulfuric acid can be used?
We know you can use all the different acids. It depends, the choice depends on what you need from feeding elements. So when you need nitrate, you can take nitric acid, but if you need a part of phosphate or you need sulfate, you can also use sulfur acid or phosphate acid. You can use the different ones. You can also mix them.
Okay, thank you very much. Yes, thank you very much for this whole overview. So this was with the focus on berry growing into the soil. Just to summarize very quickly, shortly. First of all, watch the soil where you're growing it in, do the soil analysis, look at the water, also a water analysis, and then they have to make a standard recipe, and they can find it at Delphi. They can contact you anytime. And of course, in half an hour, these different crops. But it gave a very good impression of where you have to start with. Okay, thank you very much. Stay with us because we are going to the next speaker. That is Marcel de Jong from Bodem en Groen. Marcel is going to tell us about the world of regenerative agriculture. And that is really a fancy new thing. Is it old-fashioned or is it just new? Well, Marcel, you are going to tell us all about it. To you is the floor.
Okay, thank you. I'm clear?
Yes, we can hear you well. And
Okay.
we see that you are sharing the screen now.
Is it visible? Okay.
Yes, all is good. Continue.
Okay, thank you. Good afternoon also from my side. I'd like, first of all, to thank the organization that give me some opportunity to share some experience that I have with the regenerative agricultural. I will start, first of all, I'm Marcel de Jong from Bodem en Groen. That means soil and green in English. I ask Valerie to translate it so that you can understand it also. I'm a consultant. I mostly work in fruit crops, strawberries, raspberries, blueberries, a little bit of blackberries and currants. I do a lot of in soil, in substrates, but also all kinds of other crops, fruits. But I do that usually by observing the crop, taking analysis, and look what we can improve. And mostly we do that by building strategies, programs by natural products. And about this regenerative horticulture, is it the future? I think if you start implementing the natural way of working, then you have the regenerative horticulture. And I think that's the only way that we have to go to. And how do we implement all these natural strategies into your conventional system? Think about it like you have the soil today, that you're gonna improve the soil up to the best soil in the world that was in the past in the Ukraine. So how are we going to do that? I like to start with a small...
Please, a little bit slower. I'm not catching up with you.
Okay, thank you. Sorry for it. I like to show you a little bit of a movie, a short part of Kiss the Ground. It shows how the regenerative system actually works. We see it coming up, the water is cycle goes up and comes down, and that means it stays in place, that it is always in your farm.
I'm still talking very fast. I don't think people can understand me talking so fast, so please a bit slow.
Okay. This is how the circle of regenerative agricultural in your farm can work. So what will we see if we improve soils with organic or regenerative agricultural, horticultural? That means that the soil can hold much better water, minerals, building biology, soil life, the life in the soil. I explain it a little bit later. Here you can see how that's working. If you have a good soil, like on the right side here, it can contain all the water that it gets. It doesn't fall apart. On the other hand, on the left side, you see the soil that is not a strong, heavy, resilient soil. It cannot contain water. It cannot contain minerals, so it will not stay as good in the soil and will not provide all the energy that you need for your plants. So what is the most important thing as a farmer? Most important thing as a farmer is catch the sunlight and let plants grow. By photosynthesis, the plant will transform the sunlight and the carbon in the air into sugars and oxygen. That's the most important thing of the sunlight. And you as a farmer have to be sure and take care of that the photosynthesis of the plant that transfers the carbon dioxide into sugars and oxygen. That's your job to optimize it. So, and if you do that correctly, then the plant will grow and it will produce and it will give flowers and give production. And by the other hand, and I talk about a little bit later about that, is that it will transform also a lot of sugars into the soil for the soil life. I like to introduce the plant health by the pyramid of John Kempf. Here on the left side, on the bottom, he invented the plant pyramid, plant health pyramid, and that is in a four-level stage of plant health. First stage is how you introduce this photosynthesis. The second level is how are you producing leveled up of producing high proteins. So the first stage is how you produce photosynthesis. How do you improve that? The second stage is how is the plant after the first stage producing proteins. And if they produce proteins, then there is no any disease in the soil. The plant is resistant to all the diseases in the soil. Then you have the third level. That means that the plants get shiny. That has an extra load of energy. Besides producing of fruits, it will have an extra load of energy to produce fats, and that gives a very shiny layer on the leaves. And then you have no problems, or you have less problems with all the airborne diseases like mildew, powdery mildew. And if your plant after the third level have extra energy over, it's producing secondary metabolites. That means that it has so much energy over, besides the production of fruits, that it gets almost resistant to all the diseases and fungus and insects. And it has also very strong resilience to UV of the sunlight. So on a heavy, warm day with heavy sunshine, the plant will not suffer of the heat. It is very strong, resistant to this sunlight. So how do we get to the fourth level? Because that's important, because it's nice to know, but the first two levels all of you can manage, because it's about giving the just amount, the just balance between minerals and trace elements. So you have to take care of that there is a good balance of minerals and trace elements. And the third and the fourth level, to get to the resilience and the strong plant, you need this soil life. This soil life, the soil biology, will give the plant the strength to be very resilient, and if there is a disease or insect, that it will not harm your crop. So first of all, take care of your minerals that the plant needs in the right form, in the good balance. And second of all, it needs soil life on the root system. So what do we need to get there? We need a good soil. What is a good soil? Besides of all minerals, you have this sand, clay, loam, and the good soils have 50% of the volume about these elements. Besides that, you have a number between around 8% of 50% of the volume of the soil. So the other 50% are pores, the spaces. There is no soil in it, but there is pores. That means that there is 50% of pores that in the best situation is 25% of air and 25% of water. So a good soil is containing 50% of pores with levels up with water or air, depending on the situation of the weather. If it's rain, there will be a little bit more pores filled up with water. Is it getting drier? You have more air. But this is the ideal situation. So how do we come to the, and this is how it looks in nature. You have these big pores, we call them micropores. You have the small pores, the micropores. You have plant roots, you have hyphae of fungus, you have some algae, you have some big insects, you have bacteria also, and this combination with the spores, the insects, the algae, the fungus, and the bacteria gives you the good structure of your soil. Now, there are two ways to go to a good soil. One is by improving soil life, and one is by improving the structure by the elements. And my experience is that if you go by improving the elements, then we have a quicker result. So what we like to do then, what I usually do in practice, is to look at what is on the clay-humus complex. And the clay-humus complex is the combination of clay, loam, and organic matter, the humus. So that's important. What is on that, which minerals are built up, stuck on this clay-humus complex? Normally, we see a big amount of calcium, magnesium, potassium, a little bit of sodium, a space of hydrogen, and a lot of small elements. So important is not how much of these elements are there on this clay-humus complex, but what is the balance between them. And the biggest importance is the balance between calcium and magnesium. Normally, we talk about 68% is calcium and 12% is magnesium. And this has to be on this clay-humus complex. Together, they are 80% on the clay-humus complex. Then we have also importance is the potassium. It's around between 3 and 5%. And a small part is sodium. You hear that also in the presentation before from Adri. Sodium is also important. And then we have some space with hydrogen. If you have a heavy soil that has a rich history, where we applied a lot of minerals, then normally you see that there is no place anymore, that there's no hydrogen there, but the clay-humus complex is totally filled with calcium, magnesium, and potassium, and a little bit of the rest, but it's very small. But remember, the most important thing, you take an analyze and you get an ideal situation with calcium and magnesium on your clay-humus complex. So what do we do normally in practice? We go to the field, we take samples on 30 different, a minimum 30 different plots in the field, about 18 to 20 centimeters deep. We send that sample from 1 liter to the laboratory and let them analyze. And then we see here on the left side, we see what's on the clay humus complex. The calcium in this case is 75%. The magnesium is only 15%, but we have the ideal situation from 68 to 12. 68 calcium, 12 magnesium. That means that we have too much calcium and we have too much magnesium. The potassium in this case is okay, is between 2 and 5. The natrium, the sodium is a little bit low, but that's for me okay. We also measure the pH, 6.9, is quite high, and the humus content is 4.3%. And that's a very interesting number. So if we want to go from 75-15 to 68-12, we need to do something. We give you an advice what the best way is to do, which elements you can best use. So in this case, we're gonna put some extra sulfur, elementary sulfur, and we give them a little bit of potassium sulfate. So these two together will level up the calcium and the magnesium. And why this calcium, why the elementary sulfur? This elementary sulfur is coming into the soil and comes in contact with calcium and magnesium. And then the calcium and magnesium will become calcium sulfate and magnesium sulfate. And calcium and magnesium sulfate, they easily loses on the clay humus complex. They get easily with water off. It get dissolvable in water and then it flushes and comes it available for the plant. So that's how we lower, in combination with the elementary sulfur, we lower the calcium and the magnesium from this clay humus complex, and then everything gets more and more in balance. So then on the other hand, on the analysis, also all the trace elements that we can analyze if we want, and it's necessary for the crop. We also use an analyze on molybdenum, MO. Normally, the molybdenum levels in the soils are this low that we are not necessary to analyze. You see on this side, all the big elements like nitrogen, sulfate, phosphor, calcium, magnesium, and potassium. And that's what's in the soil over there. And that will be, that's possible to become available for the plant during the crop cycle. If we think for certain crops that there is not enough trace elements, we can apply extra trace elements. In this case is like manganese. We put an extra manganese in the soil. We put an extra copper and molybdenum in the soil. So, and that's very important to let soil life grow. So if you want to know what is the level of the minerals on the clay humus complex of my soil, and what do I best supply to improve the soil, then you take an analyze where you have what's on the clay humus complex and bring it up to the good levels if necessary. So you have this analyze, you improved your soil. That looks very nice, but I show you an example what we did. So we took a sample in 2019. We had an ideal situation of calcium, magnesium, the 68-12, like we talked about. The calcium of the analyze was 48. This is this orange block here, 48%. The blue one is the ideal situation of calcium. The magnesium in 2019 was a little bit too low. This orange you see also here, and the ideal situation is blue. So we did this analyze, we supplied what was necessary to improve the soil. And then in 2021, 2 years later, we took another sample and we see that there was a huge improvement from calcium in 2 years' time with this supply of calcium that we did in 2019. So you see that we go from 48% to 62%. We are almost there, but not yet. But normally, I say to people, to my clients, okay, we take a sample today, we bring up what is necessary, calcium, magnesium, sulfur, maybe potassium. We bring that in the right forms and the right amount on the field, and then it will take 2 to 3, maybe 4 years to get to the right direction. So if we take the sample this year, I think we have it almost on the right point that where we want to be. So you see, if you take a sample and you supply on the soil what is necessary, what is advised, then you come very quickly in an improvement of your soil. Now, why is that so important? Because why should you spend a lot of money to improve your soil? First of all, I think that's the best thing to invest in, because the soil is the most important thing to grow healthy crops. But this investment will give you also a big return, a great return. So this institute, Louis Bolk Institute of the Netherlands, they did research and they say, okay, what does it bring? So if we have a soil that is 75-15, like we had in this example before, you are in the average of 4.8. That's this level. That gives you a big difference from 4.8 to 5.7. And that doesn't say anything, of course, but what does it mean for your, what is available for your crop? We have with this not right, correct balance on this clear humus complex from 4.8, we have around 310 kilos of nitrogen available out of the soil for your crop. If we bring it up to the level 68 to 12 on the clay humus complex, we're almost on the 400. That means that we have 80 kilos extra nitrogen available for your crop. So if you improve your soil, that your balance on the clay humus complex between calcium and magnesium brings a structure in your soil, then you improve your soil, that the soil life will have a space and room and air and water to live in, and that will bring this extra 80 kilos of nitrogen in this case. So we build a structure for in your soil to improve soil life. Now, what is soil life? Soil life is the factory for the total life. Soil life is a soil biodiversity, and soil life, what does it mean? What do we understand under soil life? Of course, the earthworms. You see them normally. I think it's important, if you put a shovel in the soil, you dig a hole, that you have to find at least 5 to 10 earthworms in that hole. So if you don't find these earthworms there, then something is to think about. So you see these earthworms. Of course, this guy, I call it always the mole. That's not always a nice guest to have, but if you have them, you know, I have something to eat. That means that there is these earthworms, they are usually there. Beside of what we see, are there also mites. If you look very closely, you can sometimes see them. You see some springtails, but also you see nematodes. And nematodes, we have two types of them. I have all different types of nematodes, but if we talk about nematodes, we only talk about the 13 or 15 bad ones that attack my crop. But there are thousands of other nematodes that feed on nematodes, that feed on fungus, that feeds on bacteria, on protozoa, on all other small insects and soil life. So there are more nematodes than there are bad nematodes. So, and besides that, what you can see with a small loop, but you have also the fungus and the bacteria. And I think these two last one, the fungus and the bacteria, are the most important one in your soil to improve your soil and keep your soil structure. Here you have a root, and on that root are some rounds, and we call it nodules. And there in that small bulb over there is a bacteria that produces nitrogen that's becoming available for your plant. Also, if you have these a lot on certain crops like on clovers here, it's nitrogen for free. You have also bacteria that produces nitrogen for free. So if you improve your soil, you get your soil life into action, and the soil life will work 24 hours a day, all day long, every day of the year, just for free. But you need to give them a good soil with a good soil structure. So improve your soil gives you soil life. What does it mean? Because soil life has also feeds also on sich. If we take a look at these grass roots, we see that the red dots here is the fertilizers. And if you think about that, a grass root or a root in general can only uptake minerals 2 millimeters around the root tip, just here. It can uptake 2 millimeters. That's not so much, because that's only 7% of this total volume where the plant is in. So if you can only uptake minerals 7% of the total volume, a lot of minerals like these, they are there, but the plant cannot get it. So if you get some soil life, for instance, fungus, then you have already a much bigger surface for taking all the minerals, because this fungus will transport the minerals and the water to the plant root. That means that you have already a bigger surface, and eventually you have a surface so big under your crop that all the minerals that are there are becoming available for the plant. I think it's amazing. So if you if you have a good soil structure and you have a good soil life, you can improve your mineral absorption by soil biology in that works together with the plants up to 700%. So that's a huge number. Okay, so we talked about in the beginning that the most important thing as a farmer was, how do I get as much as photosynthesis transformed into sugars? Because a lot of sugars the plant is using to grow, to flower, to give fruits, but most of it, 40% of these sugars, he puts it into the soil. And he puts it into the soil because it needs to feed the soil life. So if you let your plant grow very healthy and very strong, it has all the energy to produce flowers, to grow, to produce fruits, but also to give all the extra energy, 40%, into the soil to feed the biology and the soil life. And I always explain it that you have two engines in nature and plants. One is above ground and one engine is below ground. And below ground engine is the soil life and above ground engine is the plant life. And together they will have to work 120% to give the maximum produce. To get a resilient soil and get a resilient plant that gives you a healthy crop. So if you look at nature, then you have these different types of crops standing beside each other. And all these different type of crops, they produce on a different depth into the soil, and they have different types of root systems, and they all produce energy, carbon, sugars into the soil to feed the soil life. The more you feed the soil life, the more the soil can produce to give you a healthy crop and a high production. You see here, that's why I like so much about cover crops. You have different root system, you make a mix, it produces all year round sugars, pushing it into the soil to give the sugars to the soil life. And then you have a better growth, you're stimulating soil life, you have a higher nutrition availability, you have less in soil insects like nematodes that are attacking your plant, and eventually you bring more carbon into your soil by a higher organic matter into your soil. So I almost like to end with my presentation, and I bring to you another part of this Kiss the Ground movie. If you have the opportunity one day, or you already had, to watch the movie, it gives you a very nice, good insights how systems can work and how I think that it can be grown. But the important thing here is that it should be that you grow in a cycle above ground, underground, and that nature pushes the CO2, the carbon dioxide, into oxygen and brings a lot of sugars into the soil for the soil life. It pushes it down, and that's how plants feed the soil life, and the soil life gets the strength and the energy to bring all the minerals and water to the plant that it needs. And besides that, it's producing a glue that sticks all the soil elements into each other, that you get a sponge. And that sponge can captate water, it can easily drain water, it's a good soil. And this is the most imaginable image, that the plant can uptake all the carbon out of the air. And then it feeds, of course, the soil. And there are more bacteria and soil life in 1 square centimeter and 1 teaspoon than there are people on Earth. So don't forget that. So there is a lot of things to recover into the soil. So if you want to know what about my soil life at home, about soil life in my soil, you have 2 systems that I like to use. That's one is the microbiometer, and one is the bee crop analysis of biomakers. I use a lot.
A little bit slower, please, because it's hard to catch up.
So I like to use two sample methods for measuring soil life in soils. You have one is the microbiometer. It's quite simple. You can do it in the field, at home. You have this case with all the instruments here. That's it. So simple. It takes you 20 minutes and you know how much bacteria and fungus there is in your soil. It's interesting to use to see where you are today, and if you do something, so you think I'm going to improve my soil with soil life, and you're going to measure today, and you do an action, and you measure a couple weeks later or a couple months later, that you know from, okay, I improved my soil really because there is more life in the soil. Takes 20 minutes. It's quite simple. If you want to know what is the total status of my my soil life and what can my life in the soil do for me, or what type of diseases can I expect, then I do a sample from bee crop. I take the sample, send it to the laboratory, and a couple weeks later, they send me back the results, and you know what type of diseases there are. You know what type of bacteria and fungus and archaea there are, and they can predict from, because they know what these type of bacteria and fungus are doing in your soil, what they can do and what the soil life can do for you. That means what type of minerals will they release and make available for my plant. That means what type of diseases do they attack and control. That means that what type of hormones can they produce to help my plant grow. So that's takes longer. You have to send it to a laboratory, but you have more information depending on, for example, like Adi said, a field with verticillium, and you want to plant strawberries on it, that's a risk. With this analyze, you can take a sample and I can tell you in 4 weeks' time if it's a problem, this verticillium for your crop, or it's not. So two type of analysis. One is very quickly, you can do it by yourself. One we have to send to a laboratory, but you have more information. It's just how I use these two analyses to measure life in the soil. So I'm finally on the end of my presentation. I like to invite all the listeners, all the farmers, to try to make small steps, but start making action in small steps with regenerative agriculture to improve your total system. Think about it, talk with people about it, but start today with small, tiny steps in improving your soil and get regenerative. So, and if you have a healthy crop, then you did all the things on the right time. Thank you very much. I'm Marcel de Jong. It was my pleasure to be here today with you. Thank you.
Thank you very much, Marcel, for this nice presentation. So regenerative agriculture is actually not feeding the plants, but feeding the soil. Is that so?
Yeah, that's correct.
All right. So then we, if we do that and people can get their soil in balance, then it will release better nutrients to the crop, as I understand.
Yeah.
And it will be more resilient for diseases, yes, and
yes.
also for droughts, that it keeps better the water.
Yeah.
Very interesting. We have several questions. The main question is actually if the presentation is available. That will be on our website of Stiyka Ukraina. And then, Valerie, I need your help a bit with the questions. We don't hear you, Valerie.
The question is how the systematic use of sulfuric and nitric acid influence the life in the soil when you grow blueberries, because you constantly add acid to your irrigation water. How does it influence the soil life?
That's a good question. Thank you for that. Sulfur is necessary for producing proteins. That's one thing. If you put the answer actually is depending on how much organic matter there is in your soil or in your substrate, because that buffers a lot of this effect of nitrates. And I'm not so afraid of the sulfur, and usually I don't see any problems with that. The only thing that you see if you put a lot of sulfur, you see also a high increase of bacteria that will eat all the sulfur and transform it to something, and I don't know what, but that's beyond my knowledge. The nitrates, or in general, the nitrogen, it's more a question about how much we give. Usually in blueberries, we don't supply so much nitrogen, but you have to imagine if you don't have the balance between nitrogen and carbon, then you can have a problem for the biology. Bacteria, they have to eat 3 times as much carbon as nitrate. So if they eat 1 kilo of nitrate, they have to find 3 kilos of carbon. If there is not enough carbon in the soil or in the substrate, then the bacteria will die because of the lack of the carbon and the overkill of nitrogen, because the nitrogen and the carbon is not in balance. I hope that's an answer on your question.
Another question is which preparations or what substances do you recommend to apply for increasing the soil life when you grow blueberries in ridges?
Yes, I like to apply, but that's not only in blueberries, but also in general. Always try to apply some type of carbon. That can be amino acids, that can be some form of carbon, can be organic matter. But if you use an organic of an carbon and you want to apply it by your dripping system, your fertigation system, you need to find a liquid form, and you have different liquid carbons you can use, but the amino acid or the algae are the most suitable for this type of applications.
Two more questions, Valerie.
How much cost one analyze in lab B crop? Is it possible to do it from Ukraine? I mean, is it possible to send a soil sample from Ukraine for it? Питання було, секундочку.
Yes, it's possible. It's possible from everywhere in the world. The only thing you need to know is, you need to take a sample and you have to send it to me or directly to the laboratory. But we have these small tubes for that. What I mostly do with clients from other countries, that they send me 500 milliliters of soil, and I take a sample from that and I send it to the laboratory to biomakers. And that's a laboratory in Spain, and they do the analysis, and they analyze, including the advice, what is the result, to explain, because I think that's important. It's around 250 euros.
Last question.
Yes, it's actually 1 in 2. So the use of fungicide is actually negative, it makes negative impact for soil life if you use fungicides on your field. And another thing is, if you use organic fertilizer, is it also helping to balance your CEC complex in your soil?
First, what is the effect of fungicides on soil life? First answer is, what type of fungicide? You have different types. If you use the fungicides where you spray on the plant, for example, powdery mildew or rust, normally that's not an issue. If you're going to drench a heavy metal fungicide into the soil, that can be a big destruction for soil life. So that means that you kill a lot of soil life. You never kill all the life in the soil that there is. There's always a part that will survive because it's coming from deeper, because you don't get there, because it's under the plant. So it's very hard to kill all the life in the soil by using fungicides. In general, I always like to explain that the use of a fungicide with a drench, you give a lot of water, or you put it by drip irrigation, you kill up to 60% of your soil life. On the other hand, you see, if you have a disease and you like to kill the disease with the fungicides, you cannot kill all the disease with the fungicides. Not in soil, not in a pot culture, not in substrates. So the same with soil life, they will be attached. A part of it is getting destroyed, but a big part will survive. So there are two applications of fungicides that can make a difference. And there is another thing with fungicides. Soil life is very resistant. If you apply one time a fungicide, it will not harm so much. But if you keep on applying every week, every 2 weeks, every 3 weeks, then they building up and you knock them down again. That will give them stress, and finally a lot of it will be destroyed. On the other hand, if you like to apply some fungicides into soil and you put together with the fungicide carbon, an amino acid, an algae, liquid carbon form from sugars or something, humic acids is also very good of it, then that doesn't attach together with this carbon. It doesn't attach so much the soil life, because these carbons that you mix together with the fungicides will be a small layer around the molecules of the fungicide. And for a bacteria, it doesn't matter if there is something in that carbon layer around that fungicide, because it eats it and destroys the fungicide. Not all of them, but a lot of them.
No, but I don't understand. Just to explain, if you apply, say, sugar together with the fungicide, is it good or bad? Why do you do it? To feed the bacteria? What do you mean?
Yeah, it doesn't harm so much the soil life together.
Okay, thank you very much. There are more questions coming in, but I like to finish. If everybody has questions, then please contact Valerie or me or Marcel or Adri directly. I like to thank everybody very much for keeping with us or staying with us till the end of this webinar. I also like to thank all the companies in Stiyka Ukraina who are supporting us to do these webinars and also other events in Ukraine during the war. In 2 weeks' time, there is a new webinar about berry production, different berries, about raspberries, blueberries, and strawberries. So I hope to see everybody again. And take care, and thank you very much for being with us. Bye.
Bye.